Hello all, in this video lecture I am going to explain you the parallel form structure for realizing the IIR filters. So without taking much time, let us go into the topic directly. So here the parallel form realization of the IIR filters can be obtained by performing a partial fractions method. This is the key point method you have to remember. So if you are seeing the parallel form realization, parallel form in the examinations, you have to remember that you have to obtain the partial fractions and the given equation you have to represent in this form. So in this form is C plus sigma k is equal to 1 to n ck by 1 minus pk into z power minus 1. So h of z they will give you. If they are not giving the h of z, you have to obtain the h of z also. But after obtaining the h of z, you have to convert the h of z into this form. So this here C is constant, C plus sigma k is equal to 1 to n ck by 1 minus pk into z power minus 1, and this term you are going to obtain by the partial fractions where pk is the poles. Okay, let us go to the problem so that you can understand better. So now see the problem. Realize the system given by the difference equation y of n is equal to 0.1 into y of n minus 1 plus 0.72 into y of n minus 2 plus 0.7 into x of n minus 0.252 into x of n minus 2 in parallel form he has given. Okay, see in parallel form, see here the difference equation has given. Okay, right, he didn't specify the h of z. Sometimes in the examinations they may give you the h of z also. If you got the h of z, then start from the partial fractions. If you are not having the h of z, then convert the given difference equation in to write it in the h of z. Okay, and you all know how to write the h of z from this equation, simply by applying the z transforms and keeping all the y of z terms into one side and keeping all the z of x of z terms into another side. And if you write y of z by x of z, the total will be converting into the h of z form. So that has been explained here. See, the first target is writing the given difference equation in terms of the h of z. For doing that, I am applying the z transforms here. So the if you apply y of z, these z transforms, it will be converted into y of z minus 0.1 into the z transform of y of n minus 1 is y of z into z power minus 1 plus 0.2 into y of n minus 2. The z transform of this term is 0.72 into y of z into z power minus 2. Similarly, this 0.7 into x of z minus 0.252 into x of z into z power minus 2. So after taking the common of y of z, bring all the y of z terms into one side, and x of z, leave all the x of z terms into another side. So you can write y of z by x of z is equal to, so this is the equation 0.7 into 0.252 into z power minus 5. So this will come into this place. So 1 plus 0.1 into z power minus 1 minus 0.72 into z power minus 2. So this is the h of z, right? Now you got h of z. So in a parallel form, you have to write the h of z as this. This form you have to write C plus sigma k is equal to 1 to n ck by 1 minus pk into z inverse. For writing the h of z in this equation, the simple thing you have to follow is simply division. See, simply division. I am dividing the this numerator with this denominator. So for writing that, so z power minus 2 is a high power, right? So higher order, right? So 0.7 into z power minus 2 plus 0.1 into z power minus 1 plus 1 equal to minus 0.252 into z power minus 2 plus 0.7. Okay, so I'm dividing this equation. Okay, after dividing this equation, to cancel the z power minus 2 terms, you have to multiply 0.72 with 0.35. So if you multiply 0.72, this total entire equation with the 0.35, you got the equation as minus 0.252 into z power minus 2 plus 0.035 into z power minus 1 plus 1. So if you cancel this, and this is the remaining thing is 0.035, and this is the constant 0.7 minus 0.35, you got 0.35. So you can write this equation as this 0.35 here, 0.35 here, and the remainder is this 0.35 plus, sorry, 0.35 minus 0.035 into z power minus 1 whole divided by the division this one. So 1 plus 0.1 into z power minus 1 minus 0.2 into z power minus 2. So guys, keep remembering this. So if you want to convert the h of z into the required format like C plus sigma k is equal to 1 to n ck by 1 minus e power minus pk into z power minus 1. In that form, if you want to have this, the simple thing you have to remember is divide the apply the division. So you got this. Okay, how you got this? Simply doing the division. Okay, so I have taken now this as a constant, now this and this. Okay, now for this you have to convert the again into the partial fraction. That into the partial fractions I have to write the roots of this equation. So I'm splitting this equation as 1 plus 0.1 into z power minus 1 minus 0.72 into z power minus 2. So I have to, if you multiply these two, I have to get 0.72. If I add or subtract, I have to get 0.1. So this is 7 to 8 nines, I think, 0.8 into 0.9. So you can slip. You have to have 0 plus 0.1, right? So I'm taking the 0.9 into z inverse minus 0.8 into z inverse I'll take. So if you multiply 0.8 into 0.9, you will get 0.72. If you add you'll get 0.1, right? So like that I have splitted this equation as 1 minus 0.8 into z inverse plus 1 plus 0.9 into z inverse. So the total equation becomes like this: h of z is equal to 0.35 plus 0.35 into minus 0.035 into z inverse. By total, the denominator has been split into this 0.1 minus 0.8 into the z inverse of 1 plus 0.9 into z inverse. Now keep it as this as a constant, keep it as this. Now let us break this as using partial fractions. Now splitting about this term into partial fractions, you can write it as a 0.35 minus 0.035 into z inverse whole divided by 1 minus 0.8 into z inverse of 1 plus 0.9 into z inverse is equal to the first order partial fraction. So you can write it as a by 1 minus 0.8 into z inverse plus b by 1 plus 0.9 into z inverse. Now if you do the cross multiplication and finding the values of a and b, you will get the a value is 206 and the b value is 0.144. So if you have, you can check this. The equation as this. So total h of z will turning into 0.35 plus 0.206 by 1 plus 0.9 into z inverse plus 0.144 by 1 minus 0.8 into z inverse. Now you got the equation as in the required format. So one is c is c plus this is h1 of z plus this is h2 of z. Now you know h1 of z, h2 of z can be represented by using the direct form 2 structure. Now let us write the h1 of z. h1 of z is c. I told you know the hint point. The first one comes for the y of n and the denominator comes for the x of n. So and if it is having plus, you have to write it as a minus. So take the one delay element of this. Delay element I have taken here. This is the representation of this, and for this I am implementing it as a this. Okay, for better understanding of the direct form 2 structure, you can see my direct form 2 structure explanation in detail, but here I have drawn it very simple way. Okay, now you have to implement these two as in parallel by one, and 0.35 is the above one. So this is the structure, this is the first structure, and in below this I have implemented this structure, and above this I have implemented this 0.35. See here, see the final structure. This is the h1 of z, this is the h2 of z, and above this I have implemented the constant. So this is the final structure of the form. So see this, and if you have any comments, please comment me in the comment box, and you practice for the remainder of problems.